Hello everyone and welcome back to our channel Quaint Cosmos. Today we are stepping into the future, a future beyond qubits, beyond today's quantum computers. You know, today's quantum computers are built on qubits, which represent 0 and 1 simultaneously through superposition and entanglement. This is well known to you. But there are so many problems with qubits. Mainly three problems are there. First is extreme sensitivity to noise and decoherence. Next is cryogenic cooling requirements near absolute zero. And third one is error correction is hugely expensive and unstable. So these are the problems with qubits. So these are not stable. Scaling is almost impossible right now because for practical applications or industrial applications, millions of qubits are required. Millions of qubits are required, but at present actually few hundred qubits are being used in quantum computers. And scaling to that limit, millions of qubits, okay, that is extremely difficult at present with quantum computers using qubits. That's why scientists are now talking about, or they are conducting their research work in another field which are actually beyond qubits. These are actually alternative quantum information units they are using. The scientists are using alternative quantum information units, and these are actually beyond qubits. These are more stable, more scalable, and are capable of performing computations faster than quantum computers. Or few problems are there, actually quantum computers struggle with those problems, and here our new generation of computers can solve those problems easily. They won't struggle at all. So actually so many candidates are there, and here in our today's video we are actually talking about only three candidates. These are the three most promising candidates. First is Qudits, second one is topological qubits, third one is photonic quantum computing. So Qudits, not qubits. Qubits, this is known to you, being used by quantum computers. Qudits, you know qubits, that means here only 0 and 1, two digits are there, 0 and 1. But here in this case of qubits, so many digits are there like 0, 1, 2, 3, 4, etc. Okay. So actually qubits store multiple states like 0, 1, 2, 3, 4, etc. in a single unit. This is the advantage of using qubits. Not only 0 and 1, but it is more than 0 and 1 because 0, 1, 2, 3, 4, so many digits are there. That means more information per particle. So fewer particles are required and faster computation we are getting. Means we are getting faster computer this way. And researchers are already building Qubit based processors in trapped ions and photonic systems. Next comes, this was the first one, Qudits. Okay. Next one is the topological qubits. These are actually based on braiding quasi-particles called Majorana zero modes. These are more stable. That means almost no error correction system is required for topological qubits. Okay, this is also new generation of topological qubits. Almost no error correction system is required for this thing, and scientists are expecting that in the next 1 or 2 years we can see the use of these topological qubits. Means computers based on these topological qubits. We are talking about actually computers based on some technology. Third one is what? Photonic quantum computing. So in case of photonic quantum computing, actually light particles, that means photons are used to store and transfer information. What is the advantage of using this one? Advantage is that no magnetic disturbance is there, no cryogenic cooling is required. Here, in case of photonic quantum computing, cryogenic cooling is not required and no magnetic disturbance is there. So these are the advantages. And already tech giants actually, they are moving from research. Research was going on, okay. Till now research is going on, but they have already started moving from research to practical applications. That means in the coming year, in the year 2026, we are going to see the use of this new generation computers. So the tech giants are actually moving from research lab to these industrial applications. And again, hybrid computing systems are also being planned to use in the next year. That means that is what? That is post-qubit. Whatever be the technology, but that is post-qubit plus AI, that is artificial intelligence, plus cloud supercomputing. Okay, combined effect of this is known as hybrid computing. And by using this, what we can solve? We can accelerate the cancer drug delivery, discovery of cancer drugs. This process we can accelerate by using these post-qubit computers. We can accelerate the discovery of cancer drugs. We can easily solve the weather models. Means climate models actually. Those are mathematical problems, and by using today's supercomputers actually it takes decades to solve the problem. But by using post-qubit computers, we can solve the same problem within few hours. Climate modeling, we are talking about climate modeling. So in the field of medicine, in the field of climate modeling, in the field of drug discovery, whether it is the drug is for cancer or any other disease. But everything can be accelerated by using this post-qubit computers. Again, cryptography. There is also, you will find the use of this thing. Because today's encryption methods are actually weak. If you think about those post-qubit computers. So actually these post-qubit computers will force cybersecurity officers or cybersecurity research team to make what? To make new cryptographic techniques. Okay, again, in case of advanced materials, design of advanced materials like supercomputers, then fusion reactor components, these post-qubit computers could be used to solve the problems. So whether it is the field of healthcare, whether it is national security, whether it is artificial intelligence, you will find applications of this new generation of computers, that is post-qubit computers, in almost all the fields, because in all the fields challenging problems are there. Scientists are waiting to solve those problems because of lack of computation facility. Problems are there, problems are ready, but such computers are required to solve those problems. Problems are already existing. Okay. So this was all about today's topic, and the year 2026 is mentioned in the video title. You can see, because in the coming year, in the year 2026, we are going to see some use of post-qubit computers. And really, if this becomes, scientists are expecting this thing, okay? And if really these things become possible in the next year, so we can see, this is expected that we'll be able to see drastic changes in so many fields. Anyway, so this was all about today's video. This is the end. If you found this video fascinating, so please like, share and subscribe to our channel. This is the end. Thanks for watching.